Hi all. In this video tutorial we will talk about how we can use nullclines to deduce the vector field in the two-dimensional state space. In class we looked at a system that was fairly complicated because it had two x nullclines and two y nullclines, and that made finding the vector field somewhat more challenging. So here we'll develop a systematic approach. Now we know that nullclines divide up the two-dimensional state space into regions where the x dot and y dot vectors are either positive or negative. So if you cross over the x nullcline from one region to another, the direction of the x dot vector will change signs, but the direction of the y dot vectors will remain unaffected. Likewise, if you're moving across a y nullcline from one region to another, the direction of the y dot vector will change signs, but the x dot vector will remain unchanged. The direction of the x dot vector will remain unchanged. So we are going to use this information to systematically build up what the vector component directions will be like in each of these regions. First, we should also mention that the x and y nullclines, they intersect at the fixed points of the system, and those are the red and green lines here. They're intersection points of the fixed points marked in black circles. Okay, so we will start by picking a point anywhere in this 2D space. Let it be this region that's marked in blue. We will pick a point and we will use those coordinates to figure out what the direction of the x and y dot vectors are. And we will find from our system equations that they're both negative. So we will mark this with arrows pointing in the negative x and negative y directions. Next, we will move over to one of its adjacent regions. Let's say we will move over to this region that's marked yellow. And when we do that, we cross over the x nullcline, and so the direction of the vector field will be such that the x direction will be opposite and the y direction will be the same as before. So it will look something like this. And now we can carry out this procedure and move over to its neighboring box. Let's say this pink region. And this time, in going over from yellow to pink, we crossed the y nullcline, and so this time the y direction will change signs, but x will stay the same, and this will be the resultant direction of the vector fields. Now the choice of how we hop from one region to another does not really affect the outcome of the vector fields, as long as we remember to cross over only across a nullcline. That is, you can move from one region to another as long as there is a nullcline at the edge in between the two regions. But you cannot apply these rules by crossing over a point. Now we will apply this procedure and we'll move from one region over to another, and in this way deduce the vector field in all the regions in the state space. Now that we know the vector field everywhere in the system, we can also deduce the flow along the nullclines. So for instance, the flow along the x nullcline will be in the vertical direction, and its sign will be the same as the vertical flows on either side of the x nullcline. Likewise, the flow along a y nullcline will be in the horizontal direction, and the signs will be the same as the sign of the x flows on either side of the y nullcline. Now, just to make sure that we did everything correctly, we will superimpose the stream function calculated by Mathematica onto our graph, and we can see that everything agrees, it's all good, and we should be good to apply this procedure to any two-dimensional system and get correct results.